Okay, welcome back. We're going to be talking here about database management. Okay, so there's a couple terms that I want to kind of throw out here as a starting point. I want to make sure uh, we're comfortable with some of the terminology that we're going to be using here. Okay, um, so we start off with a database. So definition of a database, we're going to call it here. There's a couple different. If you look around, there's a couple different ones, but for our purposes here, we're going to define a database as being a group of related files. Okay, and then a file is a group of records, all of the same type. All right, same structure, same layout. Um, and then a record is a group of related fields. Okay, and then a field is a group of characteristics as in words or numbers. Okay, so we kind of look at the hierarchy of this. So we kind of if we want to work our way up from the bottom, we have fields, which really just are defines a particular fact. All right, so it would be like a telephone, like somebody's telephone number would be stored in the field, or their address would be stored in the field, or their age would be stored in a field. We take a bunch of fields, we collect them, we group them together, and it creates what we call a record, all right, which is a group of related fields referring to one thing, all right, a single person. All right, one person would have one record, I guess theoretically. If we take those records, or we group all those records together, we store them, we create what we call a file. And then if we have multiple files and we group all the files together, we'll call that a database. All right, so that's kind of a top down, it's a hierarchy of it. Now, there's other terminology. Now, one of the things that's challenging about when we talk about databases is because of the origins of relational theory, relational database, which is based on relational theory, a lot of terms will any particular thing could be referred to as multiple names under different names. So some things are, an entity is the same thing as a table, and an attribute is the same thing as a field. We'll see it as we go forward, but it's kind of so you've got kind of the theoretical basis of this stuff, entity and attribute versus field and table, which is like the physical implementation of it or logical implementation of it. All right. So, so file systems have been around since as long as we've had computers. All right. What you do is you read what the idea is that you collect a bunch of data elements together, structure up into records, put the records into a file, and then you read the file. Computer program will, you can open up the file, read it, bring all the data in, and process it. Okay, and we have different files, or for different applications, different functions, different departments. All right. So the challenge with that is that you can have files all over the place. All right. So I can have multiple files. One's referring to the same thing, but it really are structured differently, and they refer to different applications because there's an application to file relationship. All right. So what that leads to is we can actually have data redundancy. So we can have data that can be stored the same, reference to the same thing. Say, for example, we have an asset. I could have 4 different applications which actually will refer to this asset, and they will be stored in 4 different files. Same data, but redundant data. And then data redundancy puts us on the path to data inconsistency. So the more redundant data we have, the more chances of things getting out of order, or and then you run into the question of what's the correct information, or what's the correct data. As we indicated, the program data dependence, so an application has a one-to-one relationship between a program and a data file. All right, so it's not, as we found, wasn't the most flexible way of doing things. Also, it wasn't particularly secure because there wasn't in a lot of cases there wasn't a lot of built-in security. There's no inherent security there. And if you like, for example, if something was backed up on tape, if you took the tape, basically you took the data that was on the tape. All right, and then finally, there's no data sharing. So obviously, you're dealing with kind of the type of environment we're dealing with. There was no data sharing. There was no data availability. It was pretty much a one-to-one program data relationship. All right, so we come along with a database management system. All right, so a database management system, the thing to remember about this is it's, the key word we're, uh, we're looking for is this idea of it's a system. Right? So what that means is it's a software, it's an application whose job is to manage the database. All right, so we have a database which is a collection of files, which can be accessed, and then the DBMS is the mechanism by which we access those files. All right, so there's a physical database which is a collection of files, and then the DBMS, which is software. And what it does is it sits between the application and the actual data files and separates the logical physical views of the data. And what it's designed to do is eliminate a lot of the problems we had with the file environment. Right, so it gives us the ability. I'll emphasize this. It gives us the ability to control redundancy. It will not control redundancy automatically. But if you implement it correctly, you can control redundancy. You can eliminate inconsistencies. What it does it does separate the programs and the data. So what happens is multiple programs can access the same data, all right, independently, all right. And then what it enables us to do is actually we can manage this as an asset. So we can manage this data, which is, as we said, data is an asset to the organization. We can manage that centrally. All right, so an example here, this is going to be an example of a HR application or human resources application. All right, so it would have a human resources database at the heart of it, which would contain all of the information regarding the employee. So the employee, their name, social security number, the position, date hired, gross pay, gross and net pay, information like their pension benefits, healthcare, all that stuff would be contained in a file. All right, so this is the database. The DBMS, okay, which is the software that sits between the database and the application. All right, so this could be an application that does payroll. So we're interested in the payroll, what we call a payroll view. So we only want to see the name, the social security number, and the gross and net pay. All right, we don't care about life insurance or pension benefits or other things. Whereas the benefits view, we'll want the name, social security number, and information about the healthcare. Don't care about pay. All right, so this gives us, so you get an idea, this is a common resource that can be used by multiple applications. And the thing it allows us to do is the database management system is the platform, is the software that lets us do this stuff. All right, so the model we talk about is a relational database. All right, so it's based on a model developed by E.F. Codd in 1970, where he adapted relational algebra and created a database management system, or the theory of a database management system, involving tables and the relationship between tables. All right, so every data is in a relational database is defined as a whole bunch of two-dimensional tables. All right, and what happens is you can have as many of these as you need, depending upon your application or your development. Okay, so the table contains. It says here will contain data about the entity into attribute. All right, so what that also means is it's the table, which is an entity, aka table, attributes, aka fields. All right, so the terminology you'll see here is, the physical, or your the non-mathematical definition. So rows are called tuples. So those are records. So every row in a table is a record, a collection of related fields. Every column represents an attribute. All right, so the idea is if I say this second field here, the second column, is the phone number, what it means is every entry, everything that's in that column, if I have, I have 4 here, I could have 4 million rows in this database. Everything that's in this field is a phone number, because that's what I said it is. All right. And then, in addition, what we have is a couple of the things. Now, these are all rules that Cott had put together. So I think there's like 7 or 9 rules that make up his, what his set of rules are, what makes up a relational database. All right. So one of the rules is there has to be a key field. So there's one field that we designate in the table that will make every row in the table unique. All right, so, for example, Social Security number. There's no two people, theoretically, no two people with the same Social Security number, right? So what will happen is if you use the Social Security number as a key, that would make it unique. And a long time ago, that's what a lot of times was done, Social Security number, until people realized the security implications of using Social Security number. A lot of times what we'll do is they'll just simply use a sequential number. So 0, 1, 2, 3. And all you need is one value that makes this field unique, and that matches the rule. So that we call that the key field. All right. And there's a couple different ways. There's a couple different types of key fields. So one key field is what we call the primary key. All right, and that's the field that we designate that makes each row unique. All right, so there's only one. It can be one. It can be more than one. So you can have 2 or 3 or 4 fields defined as the primary key. The thing we have to make sure is it simply is going to have, it's going to make it unique. That's the main thing. And then we have something called a foreign key. All right, so a foreign key comes into play when we're going to link 2 tables together. Right, if I have 2 tables, what Codd's relational theory says is if I have a field that's in common between 2 tables, right? If this field is equal to that field, the same field, what happens is I can join these 2 tables together and access all of the different fields that are in there. Okay, so let's look at how that plays out. So this is an example. This is a better picture of a relational, couple of relational tables. All right, so as you can see, we have a supplier and a part. So this is the supplier table that contains supplier data. This is a table that contains part data. Right, you can see we have different fields, and you can see we say the columns. The column, because it's the vertical column, can also be aka known as the attribute, aka known as field. So you'll see all of these terms, and sometimes these things simply get used interchangeably. All right, so it's just they all mean the same thing. They're just different. They come from different origins. So we've got rows, which are also known as records, which are also known from a mathematical basis as the tuples. Okay. And we can have any number of rows in this database as long as we've got physical space to store it. Right? So we can, a relational database can contain millions of rows. Right? And then, so we have two tables. So we have one table, and then we have, as we say, this first field, the supplier number, is the field that's identified as being the key field. And as we said, the characteristics of the key field is unique. Right? It makes this row unique. There are no other rows that have 8259 in it. All right. And then we have a second table. All right. So this is the part. So the way we describe this relationship is a supplier can supply many parts. All right. And a part has to belong to one supplier. All right. It's just simply so what happens is as we're designing this stuff, what we're really doing is we're representing the business rules, the rules of something. Like, what's the relationship between our suppliers and our part numbers? We're defining that, and putting it in kind of showing it in a table form. Okay, so we've got two tables. So obviously, we just said every table has got a primary key. So in the second table, in the part number is our primary key. Right? And then what we have is a supplier number. All right. This is the foreign key. The foreign key, which points to so the supplier number and the supplier number are the same. So this is a primary key. This is a foreign key. All right. So, and what we now have the ability to do is these two tables are now linked together over this common field. So what I can do is I can read this table, and I can say 8259, which is our first supplier here, and say, all right, show me all parts we buy from 8259. What we can do is we can follow this path, and we can say, okay, well, this one, and this one, and this one. And if I ask for that, so just find all of my tables, and we can enter a command which says, okay, tell the database management system, look, find all fields that have 8259 in it, and it'll create a return, what they call a return set. It'll return that back, and we can process it. All right. So as I said, COD developed this using relational algebra, which is really, if you recall, set theory. So set theory has a couple different, you have collections of numbers, or collections of, I guess we would call them attributes, and you can match the characteristics across these different sets. So you can see, okay, what do the two sets have in common? What do we have between the two sets that are different, that are unique to each set? What is the intersection between two? What is the intersection of the two sets? And what would be a null set? Or if there's something that is in neither one, that would return a null set. All right. So those are all. That's the mathematical part of it. It translates to, tables and columns and rows and relationships. Right? Hence the relational database name. All right. So the operations we have, and this is derived directly from the relational algebra model. A select is where we will create a subset of a table where all the records meet a criteria. So I can check every one of these. I can check characteristics. I can say, give me everything in here which the supplier comes from Ohio. Or I can say, give me everybody who's in Ohio and who comes from Dayton. All right. And give me everything that's Ohio whose zip code, Ohio, Dayton, in this zip code. All right, and I can retrieve all of these data, based upon what my selection criteria is. So I can find anything in the table. I can either return the entire table. If I just simply say select, I'll get all data in the table. But then I can also say select where certain values are equal to certain attributes are equal to certain values, and it'll bring back that data. All right, and then when we have the ability, so I can take a select, and I can combine a select with a join. So what a select will do is a select will retrieve a subset of the data. A join will allow two tables to be connected together via the primary, the key, the foreign key, and the primary key. All right, so I can select data from this table and this table, where the supplier number is equal to the supplier number. So that's known as a join. All right, so we combine relational tables together to provide the user with more information. And then we have what we call a project. So a project is I can create a table. I can do a select, join a couple tables together, or I can select a couple joined tables together, and I can get a result we call result set back, and then the result set I can use to create a whole new table. So these are the basics. So this is just the basics of the relational, of the relational model. All right. So as we see, there's the three basic operations of a table. So I can do a select. Right. I can select part number 137 or 150, one or the other. All right. And then I can join that across the supplier numbers. All right. And I'll create a result. So what you do is you do a join, or you do a select, and you can do a select with or without a join. You don't have to join. You can just select across a single table. But I'll do a select, and it will give me the results. All right, and then I can take that result, and I can either just process the data that's in it, or I could create a whole nother table. All right, so that's a select. So this would be an example of a select and a join and a project. And this is so the language we use. So the language, and you may have heard this before, SQL stands for Structured Query Language, SQL. And it's the language that we as people or programs use to talk to the DBMS that we tell this is what we want the DBMS to go find us in the database. Here's the rules we want to do. So we want to select. So what I'm going to do is I'm going to do I have a join. Okay, so we're from part and supplier. All right, now I want to retrieve these fields. All right, where the supplier number, equals the supplier number. So that's that's the common field, and we're part 137 or part 150 or part equal 150. So as you can see, we can make these things pretty sophisticated. We can look at all these different attributes and look at them in different ways and join all sorts of tables together. You look at these. You'll look at some database definitions, and you'll see something could have like 100 tables in it, all linked together, and you could write a query to process all 100 of those tables. Now, it takes a little while. It takes as you start getting more sophisticated with it. As you can see, you get pretty verbose. So, because this is a pretty simple join query. All right. So the DBMS, I said DBMSs are pretty sophisticated pieces of software. All right. So what it needs is, and what it has contained within is a whole bunch of capabilities that it uses to be able to do what it does. So it has things like data definition, data dictionary, so it knows what the structure of tables look like. Enables us to query and do reporting. So we can do what we call DML, data manipulation language, where I can define the structure. I can define what the table looks like. All right, so if I, in order to create a table, to create this, there's a command or a bunch of commands. The DML commands would say, okay, create a table with these columns, and then a description of what these columns should have. This would be this would be a number. This would be text. This would be any of the characteristics. We would define the table structure. So in the table structure, the thing we define with this DML are the rules. All right, so this is what the thing looks like. This is what the rules are for working with it. And then the SQL, structured query language, is how we get the data out. So I can do data manipulation. I can create tables. I can insert data. Once I create the tables and create the rules, I can then load data into those tables, and then I can then use the SQL to get the data out. Right, and depending upon, and there's a lot of different DBMSs. So the most noteworthy ones, the ones we see a lot of times in businesses, Oracle or Microsoft has something called SQL Server. IBM has something called DB2. There's an open source system. It's called MySQL. Oracle is one of the leaders. And then you have Microsoft Access, which is actually Microsoft's product, which actually runs on a PC. Right? And we'll be working with this. All right. So, and some, as you say here, some databases can have different functionality. Some are simple, some are complicated, but the mechanics of it, the tables and queries and all that stuff, is the same no matter no matter what the product is. All right. So this is an example of what we can, of developing a query in Access. All right. So this is which is what we call QBE. So the term is, so this is QBE stands for query by example. So what we do is we kind of draw a picture of the data. So this is all the tables in there. We drag and drop the tables. We define the join relationship between the tables, and then down here we can define what we want this thing to look like, and it will execute a query. Actually, what it does is it actually generates something that looks like this. It will actually generate this behind the scenes. So we'll be working with this a little bit, so we'll get more into this in a bit. When we're designing a database, there's a couple of different things we're concerned about. We're concerned about the conceptual design versus the physical design. All right, so the conceptual design, and the trick with the conceptual design is it has to play by COD's rules in order for you to get the data out correctly. For it to work correctly, it has to be designed. And it has to be designed in a particular way. So the term we use is something called normalization. All right, so normalization is actually, we take a bunch of data elements, we organize them, and then we kind of do an iterative process where we change, we'll kind of restructure it, and it goes through different cycles. So each cycle is called a form, like a normal form. All right, so I think there are 7 normal forms that are out there. You need to get to at least 3rd normal form before you have a working database. So practically speaking, most databases I've seen were they were at least 3 and sometimes 4. 4th normal form, 3rd normal form, and 4th normal form. Arguably, if you're a mathematician, you would argue we'd have to go to 7th normal form. But a lot of times, what happens is from a practical perspective, a 3rd normal form or 4th normal form is good enough to get the job done. All right. So what it does is we say normalization, this whole normalization process, we streamline complex groupings of data to minimize redundant data elements and to eliminate things like awkward many-to-many relationships because we're defining the relationship between the data. All right. So a couple things we see is this is the terminology of um, within a relational database, in between tables, there's something we call referential integrity. All right, referential integrity, what it refers to is the relationships between tables are consistent and correct. All right, and what that means is, we'll come here. If I have a supplier number here, right, so 8259 in the part table, right, it's a foreign key. The expectation is there is a matching 8259 in the supplier table. All right. Or 8263. There's a matching entry in the other table. If there isn't one, so if I look here and I see 8259 and that got deleted out of here, the database is broken, all right, from a relational perspective. All right, so you'll hear this term referential integrity, which is a big thing, because what happens is if you get a broken database, then you've got data in the database you can't access, and the problem is when you have a situation like that, when you query it, the answers you get back might not be correct. They may be inconsistent. So it's kind of it ties back to the mathematical basis of the relational database. All right, so it's something we'll look more at this. ERD, an entity relationship diagram, is really just a picture of what all the tables look like and what all the relationships are. All right, and we'll look at an example of an ERD in a sec here. But correct business model. This is actually a process. So one of the differences between a database and a spreadsheet. Spreadsheet is you can kind of jump on a spreadsheet, just entering data into it, and kind of dynamically do things on the fly. With databases and relational databases, what has to happen is you have to define things. You have to make sure you design it up front, define all the rules before you do anything with any data. All right. So there's a lot more upfront work with a database than with a spreadsheet. So we talked about the normalization steps: first normal form, second normal form, third normal form. All right. So first normal form, or unnormalized data. So we'll just take a whole bunch of data here. All right. So this would be in an unnormalized form. So you'll see things like you got name, address, you got movies rented, and you'll see you have multiple entries here. Multiple movies, all of the data is in one row. All right. So then for the first normal form, what we do is every cell has to contain a single value, and every record has to be unique. All right. So in this case, when we break this out, what happens is we've got, instead of having one entry with two films, we have two records, each with its own copy of the film. All right. So that's what we call first normal form. We then assign the primary key. So once again, it's a key, it's a field that makes the field unique. All right, cannot be null, has to be unique. And once we put it in place, it can't be changed. All right, so whenever you insert a new record, you give it a unique value. All right. Or now the other thing we said, we can create more than one field. The term we use for that is something we call a composite key. All right, so it's a primary key made up of a whole bunch of different columns. The characteristic, once again, is it makes every row unique. All right, so what happens is, in this case, we have like two people, same name, different addresses. In order to make them unique, you have to have both the name. You would make it name and address. The real solution is you don't use, what you can do is actually, a lot of times what you do is you just simply create an artificial key and just give it a unique number, and it works just fine. So second normal form, step one is make sure it's in first normal form. All right. And then rule number two, we identify what our single column primary key is going to be, or our primary key. And then what we will do is we will start adjusting it. So what we will look for is, kind of create it into, we'll split this thing into two tables. So instead of having, this one table in our first normal form, I have information about addresses or the customers and their address, and then we have information about the movies. Well, what we want to do is we want to kind of separate this out. All right, so what we're going to do is we're going to create a structure now. So we'll take the for second normal form, what we will do is we will take the instead of having one table with everything in it, what we'll do is we will split it into two separate tables. All right, and then what we will do is we will create a key, an artificial key. We'll call it the membership ID. All right, so that's just simply a sequential number, which you uniquely identify it. And then the membership ID is going to define our relationship between the two tables. Okay, so if you'll see, second normal form, we've got a different structure around it. We separated it by types. All right, so foreign key. So this is where we're defining what, if we have more than one table, we're defining the foreign key which ties the two tables together. So in order for this stuff to work, is you have to have one field that's in common. So foreign key references the primary key of another table, connect it. We can have a different name. Best practice would be to use the same name in different tables, because then there's less confusion, but it does not have to be it doesn't have to have the same name, but it has to have the same values. All right, so we said ensures one row, the rows in one table will have the corresponding rows in the other. And this is where this relationship here defines our referential integrity. All right. Foreign keys don't have to be unique. You can have more than one foreign key with the exact same values in it. All right. And it says foreign keys can be null, even the primary keys cannot. So, all right. So in this case, what we've got is a foreign key. The primary key for the membership table is the membership ID, and then for the information that we've separated out, we assign the membership ID, which links the two tables together. Okay, and then we have one entry per movie. All right. So what happens is why do we need a foreign key? Well, take for example, we have a situation where we're entering a new movie. All right, we're creating a record in the database because somebody's rented a new movie, right? And they come in and somebody enters the membership number of 101 in this new movies rented record, right? 101. What it will do, if you have this relationship between these two, it'll make sure that you've got a 101 in here. And if the 101 is not in there, it won't let you do it. All right. So it will help maintain, part of the stuff within a relational database is it maintains, we define these relationships, and it will protect the relationships. It will protect the data so that if we try to enter something that's incorrect or we enter bad data, it will correct, it will prevent that from occurring. All right, so in this case, if I try to enter membership 101 and there's not a matching 101, it kicks out. Now, we've got some different, we've got, as we start getting into this next, the next one, the third normal form, things get a little, this is a little, becomes a little bit more esoteric. So there's a thing called transitive functional dependencies. All right. So it's basically what this is saying is that if I change a value, if I change one value, it could have impacts on other columns. So if I have if I change the name or change the gender, the salutation might change. Okay, and the way we can deal with that from third normal form is basically we has to be in second normal form, and we have to get rid of all of these, identify any transitive functional dependencies. All right, so in order to do this, we'll split this out even more. All right, so we separated our the salutation, in the one table to another table. So the idea is now we have three tables and two relationships. We have a relationship here, right, and we have a relationship here. And what will happen is the more tables we have, the more relationships we build. So you end up seeing the kind of the cross relationships. And not all tables have to have relationships between them. Or ultimately, in order to access data, you have to, things need to be connected together. But you have a one-to-one, you have a one-to-many relationship. So for every entry we have here, we can have many here. So this is the one, this is the many. For every membership ID we have here, I can have many movies rented. All right. So this idea of which one is the one and which one is the many is the thing we always want to focus on. All right, so once we're done, once we get the third normal form, usually we have a working database, a working relational database. All right, no more transitive functional dependencies, so we're in third normal form. Right. So then we have, and then we have we have three tables with two relationships connecting things together. Right, and we had done this exercise in class, and so I'm not going to step through everything exactly as I had done. But basically, we can take this, this set of data elements, and we can organize them. Basically, we can split it into four tables. A table related to the part number, primary key of the part number, a supplier, which is the primary key of the supplier number, an order number, which is order and date, all right, and then a line item for the order. All right, so if you look at this, what I have a couple of relationships here. So what I'll have is I have a relationship here between the supplier and the part number over the common supplier number field. I have a relationship here between the line item or the order and the line items. Think about when you buy something at Amazon. You go in, you can buy one to infinite number of items in the order. All right, so you have a minimum of one item you order, and then but you can do multiples, you can do many. So the idea is by creating this, I can have a single relationship. I have a relationship of a single order with multiple line items. All right. And then the next thing I have is I have a relationship between the line item, the part number, and the part number here. Okay, so in order to place an order, In order to add line, you'd have to create a line item, and then whatever I order, it has to match. If I'm going to buy a part, it has to match the part number, because I can't put an order without it. So this line item you see has really two relationships with it. One is a relationship to the order, a relationship to the line. The relationship between the part actually goes back to the supplier across the supplier number. All right, and with this kind of arrangement, I can pretty much, this is actually a standard. What happens with a lot of these things, for suppliers, for orders, for order type of applications, this is pretty much this is what it looks like. There might be some subtle differences here and there, but for the most part, this is a pretty structured. This is how most supplier applications, order execution systems are organized. So referential integrity, which we had talked about, we need to make sure that all of the references are valid. So if I have a field here, in my part table, if I say there's a supplier in here, there better be a supplier in here. And the thing to remember is, if I delete this supplier number out of the table, what has to happen, what the database will do, database management system will do, is it'll come back up here and it'll take out any parts that match. All right, it's like a cascading, I guess we call it like a cascading delete. And every table, every entry I take out, it will, and then also go back and it will delete the part number. So you see this cascading. If I delete one table, one entry in a table, it'll take out all of the parts associated with that supplier. And then as I take out all the parts, it should update, or it has to do something. We have to do something about the part number. Because otherwise what will happen is we'll come back in, we'll look at all these orders, we'll see these part numbers and say, well, what does that part number actually do? And it doesn't exist anymore. So you have a broken database. All right, so this is what we mean by referential integrity. And so the fancy term is, or the fancy definition is, a value of one attribute of a relation references the value of another attribute, then the reference value must exist. So an ERD, which stands for Entity Relationship Diagram, which is a picture of all of these relationships. So if you get an ERD, when you create an ERD, or if a database administrator, designer creates the ERD, you can look at the ERD and really understand the nature of the relationships between everything in the table. All right, so it's a map defining all of the relationships. So what we do is we define the entities, which are tables, their attributes, their fields, and the relationships between everything. Right? So an ER or ERD shows the logical structure of a database used to sketch out the design of a database. So this is a standard tool that the database designer would use, and this is how you would manage. When you create the database, you would end up at the endpoint. When you're done, you create the ERD, which defines, and actually a lot of these DBMSs will let you basically draw a picture of it automatically. And that is everything we need to know about relational databases.